Welcome back. This is the last formal lecture before the midterms. Yesterday, we introduced the macroeconomic concept of GDP. Today, we're going to explore what happens when that GDP grows, and we're going to introduce two other macroeconomic concepts, notably inflation and unemployment. So let's start with the idea of growth rates. And this idea applies to most economic variables quite broadly, and even beyond that is a mathematical formula that we'll explore outside of econ on the next slide. But specific to what we were talking about last time with real GDP, we often focus on growth rates, which essentially are changes from year to year. And growth rates can help us provide better information about the economy. Because we don't just want the economy in its stable or stagnant mode, but we want to explore its dynamism. We want to explore how it's changing. So which provides more information? Whether or not US real GDP was 15,994.3 billion, or whether it's growing at 4.3%. And growth rates can tell us changes relative to other years. It can tell us whether these changes are increasing or decreasing. And to explore them, it's important to understand that GDP in and of itself is a flow variable. So change is often more important than the actual level. And what we're looking for when we explore GDP growth rates is how the economy is booming or busting. We're looking for the business cycle, these short-term fluctuations around a long-term growth trend, which means we're interested in changes and growth rather than absolute levels. So the formula for calculating a growth rate is very simple. We calculate it as a percent change, which is new minus old over old, and then we multiply it to put it in percentage terms. So let's go over that again for those of you who are less familiar with math. It's a new value minus an old value over that old value, and then we just multiply by 100. So we can use this to calculate the growth in everything. How much taller you are than you were last year, how much more money you have than you had last year, or the change in the US economy, the change in real GDP. We're also going to use this growth rate formula to calculate inflation rate and unemployment rate later in this lecture. So it's really important that you know this formula and that you're familiar with this formula. So those of you who are less comfortable with math, please do send me an email or make an office hours appointment. But roughly, if real GDP goes up 2%, and price level goes up 2%, then nominal GDP would have gone up by 4%. Let's practice using this formula from the real and nominal GDPs we calculated in the last lecture. So last lecture, we calculated that nominal GDP in 2018 was 90. Since 2018 is the base year, that's also real GDP in 2018. We also calculated nominal GDP in 2019 was 170, and real GDP in 2019 was 122. And we can use these numbers to calculate a growth rate. Again, using that formula, new minus old over old. So the growth rate in nominal GDP from 2018 to 2019 was 88%. The growth rate in real GDP from 2018 to 2019 was 35%. But why do we care about economic growth? Well, economic growth is a long-run growth rate of real per capita GDP. Remember, real means accounting for price changes, and per capita means accounting for population changes. So economic growth is the long-run growth rate of real per capita GDP. And more growth typically means higher standards of living. This is what we were talking about in that last lecture. More growth typically means higher standards of living. And this is correlated, though not one-to-one, with many other standards that we are interested in as future leaders, as individuals, as members of nation states. So higher economic growth, faster economic growth tends to be associated with wealthier countries, which tends to further be associated with greater lifespan, less infant mortality, more nutrition, greater healthcare, more freedom, more access to education. And this is surprisingly a relatively recent development in terms of history. For most of human history, living standards did not change. Yet now, in this post-industrial society, living standards are improving year to year. But this is an aggregate term, and growth is not evenly distributed around the globe. And for those of you that are interested in this, you should really look into taking Dr. Hardy's Economics of Poverty class. But broadly speaking, understanding why different growth rates exist, understanding the why of different growth rates may help us get to a how. How can we even out global distribution of growth? And specifically, why might 2% versus 4% growth be normal or abnormal, and what are the implications of that? So to put that in the context of US history, in the US, just like worldwide, economic growth is a relatively recent experience. It was basically zero before the year 1800. The US economy grew at a 0.02% rate. It's only in this post-World War II period where we see about a 2% growth rate. And we can take that growth rate and compare it to tangible things we've experienced in that time. So in the years between 1960 and 2010, we saw an increase in life expectancy. We see a lower percentage of our income dedicated to food, and our work week has decreased. So with economic growth comes these other things that we've been talking about: greater access to education, greater nutrition and healthcare, greater lifespans, decreased infant mortality, and so forth. But you'll notice that this difference between 0% and 2% doesn't seem that large, and what we're seeing is the importance of compounding. So even very small differences in growth rates can lead to large differences in economic wealth over time. Compounding means more today means much more in the future. And it's one of the reasons why things like environmental concerns might be so important. So if you put any value of carbon in the atmosphere, what is that carbon going to look like 10, 50, 100 years from now? And small investments today might mean massive changes for future generations. Now, compounding is mathematically complex. Luckily, we have a simple rule for how it works. It's the rule of 70. And what this is a heuristic, an approximation, it's not exact, for how long something takes to double. And what the rule of 70 is the amount of time it takes to double is about equal to 70 over the growth rate. And I say about equal, this is an approximation, it's not exact. But we can apply this formula to anything with a growth rate. How long it'll take US GDP to double, how long it'll take our bank accounts to double. It also can go in the opposite direction, how long it'll take our debts to double. So suppose the growth rate of my debt is 2.3 years or 2.3% and I'm not paying it off. My debt will double in 30 years. Similarly, suppose the growth rate, the interest rate on my debt is 6.9%. My debt will double in about 10 years. So this is a good place to end this little mini lecture with a little bit of practice. So suppose we've got 3 rule of 70 problems. Take some time to practice them on your own, and we'll come back with the answers in the next video.